Hello, grade 10, and we're back. Just to quickly touch on this chords of a circle, you don't really have it in your notes later on, but all it means is if you have a chord, so a line that goes perpendicular to your radius, it's always going to divide this chord into two equal pieces. And I'll scan some proofs for all of these, but for the moment we'll just take them as they are. Okay, so our next property is called the radius tangent property, and very important for you to understand the meaning of the word tangent. So tangent is a line that touches the circle or a curve at exactly one point. Okay, so let's take a look at what this radius tangent property is. Well, look what happens. So this is our tangent. Can you see it doesn't cross the circle, but it just slightly grazes it, just touches it. You can see that as I move it around, whenever it comes in contact with the radius, it stays as 90 degrees. So that's all it is. It just says that, and you can go ahead and just write it right into your notes under the radius tangent theorem, that an angle formed by the radius and the tangent will always be 90 degrees. Okay, so let's apply this to a couple of problems. So here we are. I'm on the next page of your packet. So in the first one, it says in the diagram below, BAC is 65. So BAC, okay, so this is 65. And now this actually takes us to property 1 for a moment, and that is, can you see the diameter and an angle? So you actually know that that's 90 degrees. That's super easy. Okay, it's a little bit confusing the way this is set up. But actually A and B pertain to this circle, and then question 2 pertains to this circle. Okay, so now we need ACB. Well, this is just super easy, and you can give a nice explanation to this. The other ones, we did this in the previous podcast. Okay, let's take a look at question 2. In the diagram above, BOC is 54. So BOC, so that's this one right here. Okay. And we are asked to determine BAE. So this one right here. Okay, one step at a time. And remember that with the podcasts, it's always such that you pause it, you figure it out on your own, and then you can see. All right, let's take a look at this angle. Okay, so this angle is going to be 180 minus 54, right? So that's going to be 126. Okay, when you're dealing with the circles and you are in this unit, always be looking for same lines, especially radii. So you can see that this is a radius, this is a radius, this is a radius. So all of these are actually going to be equal. Now, our property is such that radius and tangent will be 90 degrees. So if we can just find out this little inside bit, then we can determine the outer bit. So, well, can you see that this is actually an isosceles triangle? So this and these lengths are the same, so therefore this and this angle will be equal. So what we're going to do is we're going to do 180 minus 126. And that's going to give us 54. So 54 is left over for these two. And then we're just going to divide 54 divided by 2. And what we're doing is we're getting 27 for this interior right here. Okay, so the last step here is our angle BAE is going to be 90, right? Remember this property, radius tangent property, minus the 27, and we get 63. Ta-da! Okay. Go ahead and try the other ones. I will do this one for you. It confuses people sometimes. You may have to draw this out. Here you are also going to have to set up a Pythagorean theorem, but and same thing with here. Okay, so first of all, we're connecting to the edge, so there's the radius, and then this right here, if we extend this line, then this is a tangent, so that means that this is 90 degrees. If it's 90 degree, what can we do? Of course, we can use the Pythagorean theorem. So let's set this up. Okay, now this sometimes is a little bit tricky. Can you see this bit is x, this bit is 5. So in total, this line is x plus 5. Good. Now, let's set it up. So we're going to have, now how long is this? Oh, remember what Miss Walsh said? Miss Walsh said always look for equal lengths. You can see this is the radius, this is the radius. So this is also going to be x. Okay, so we have x squared plus 8 squared, and that's going to be equal to x plus 5 squared. From now on, you've done stuff like this. Foil it out carefully, and you're going to have x squared plus 10x plus 25. Lovely. I love when x squareds cancel out. So what do we got? We have 10x on this side. Let's take this over. And this is going to be 39, I believe. 44. Divide by 10. And you get x to be 3.9. Okay? So just remember radius, tangent, 90 degrees forever.